Hello, units for maths for finance, that is under differential equations. We looked at types of differential equations that has to be ODs and then PDs. We also considered the classifications of differential equations. We said it can be linear, it can be separable. We also looked at the other classifications like the order and then the degree of the differential equation. I hope you remember the stuffs. Alright, we talked about differential equation as a form of modeling, and in our field of specialization we look at stock modeling, stock price modeling, or asset price modeling. We said that the stock can be modeled with an ODE, which is giving us, if I'm using the stock price as ST, the small change in the stock price giving us the mean drift of the stock price at the time T. This is the model for the stock price or asset price, and I need to solve this model. Now this falls under the category of separable, so I can separate it, having it at 1 over ST dST is equal to mu dt. When it's separable in this way, we cannot integrate both sides. If I integrate this, integrating both sides, this gives me a lane function is equal to, this is like a constant. Integrating a constant becomes the constant times the differential. I know you don't want to go through this, but let me do that for those who want to know the output. Now I want to find the stock price at any given time T. To have this, it means I must take the exponential of both sides. So x2 becomes, don't forget that integration gives us a constant of integration, because this is an indefinite integral. So I take exponential of this plus k. Exponential of the length function, they are inverse, they are related, so this caters for that. That's why I have just the st. And exponential of the right hand side. Now by indices, I can rewrite this as exponential ut times exponential k. Addition of the superscript is the same as multiplying them. I can set this guy to some a, so it means I have a times e mu t. Right, so let's go back to a green pen. It means that my st is giving us a exponential ut at any given time t. But we don't know what that is, because a is exponential of some constant k. How do we get that? If we know that initial stock price, it means at time 0. So someone says at time 0, what is the price of the asset? I can set it as S0, because ST means the price at any given time T. So at 0, it means I have S0. It means that now my stock price at any given time T is given as the initial price times the exponential of the drift. This is the new solution. This is the solution to the differential equation here, star. Basically that. So someone will say, then what do I do with this? It means that if I know the variables involved, let me use the blue pen. If I know the initial price of the asset, if I know the drift or the rate of return, I know the time I'm looking for, I can find the stock price at given time 2, given time 3, given 4. These are time units. It can be daily, it can be yearly, it can be quarterly. The unit depends on what you are looking at. It can be weekly, so week 1, week 2, week 3, what is happening. That is, but you know, prices are mostly daily, so day 1, day 2, or even in seconds. That is if I dealing with high frequency data. So let's go to our Excel and see what we can do. But before that, assuming that u is not given, this mean drift is not given, how do you determine that from the solution? So I'll make it as a star. From start, I realize that if I want mu, what is mu? If it's not given, I need to find it. I can divide through by the S0, so I can have the mu, this way. So I told you exponential and natural log has a relationship. So if I want mu, it means I can take the natural log of both sides. Take the natural log of st on s naught. So it means I have lane of st s naught to be equal to exponential lane will cancel out, so I have mu t, but we are looking for mu, so what do we get? And so we'll have mu is equal to 1 on t lane st over s naught. This is something you can also keep in your pocket, given that it is not originally given the problem, but you can find it using this solution. Okay, so I can find them. I can set t to be 1. It means I have 1 over 1 lane 1 over s naught, sorry, s1 over s naught. If my time frame is 1, then I know it's 1 over 1, which is simply going to be lane of s1 over s naught. If your data set has a time frame of 2, that means you have 1 on 2 s2 over s naught, in that way. So let me go straight to my Excel sheet. I'm multitasking for now. I already have my Excel sheet, a differential equation model. I have the initial price, assuming I have an initial price of this 37.5 of the asset price. I have the price at 1. It means the next day price at 74.1. I'm looking at the daily data, so my time difference will be 1. The drift, which is a u, is giving us that. I just typed this from the deductions I made here, so don't be scared about that. Alright, so we had u to be 1 on t. Okay, so we had mu to be 1 on t lane st on x naught. That's what I've typed here, nothing more, nothing less. Now the model solution, let me use a different color here. Green should do. Okay, the model solution is what I had here from equation star. So st is equal to s naught exponential ut or mu t. I just typed my solutions and then my mu out. That is all. Now with the Excel, I can find the next prices of the assets. I have my time frame from 0 to 1 to 2 to 4. What do you think is the stock price at 0 would be? It is s naught, so it is 37.15. Do I know the stock price at time 1? Yes, it is 74. So let me just make it equal to this, so 74.3. Do I know the stock price at time 2? No. How do I do that? So I can use this model. So the model should help me get it. So this is, I can just copy. First I need to find my mu, because it's needed here. So this, what I'll do is to copy the function here and then paste it here. But I need to evaluate it. So you know in Excel, to evaluate something, use the equal sign. 1 on t, I'm using the time frame of daily, so t is equal to 1. Lane s1. S1 is here. S naught, I just clean and then I select. If you don't select the right variables, you still get an answer. So you take your time, select x1, select s naught. So that is my mu. I've computed it. So when I come here, I'll still copy this model here, copy, paste. But I want to evaluate it, so I need that equal sign in Excel to help me out. What is s naught? Let me increase my Excel sheets here. Okay. What is s naught? S naught is this cell here. Exponential mu is this cell here. And then t, it means I'm looking for the price at t0. I don't want to type 0, so I want to pick the cells. Enter. Realize I get the same answer as what I'm expecting. If you don't get this, it means your model is wrong, or it should be as close as possible to the actual price. So this can be the actual price. This is the predicted. So this is the actual price. Let me just wrap this up, and this is the predicted price. So the model gives me the predicted price. Okay. Now if I want the second one, someone will say, let me just simply drag. Fine. What is happening? There's something wrong. What is wrong is that there are some variables that are constant throughout. Your S naught is a constant variable. You may need it every time. Your mu will also be constant. It means you're not supposed to change it. What do? It means when I get here, I must get these guys to be stacked. My S naught is stacked. My mu is also stacked. It shouldn't change. But all others do change. Then I can drag it to get the other answers. Voila. Now I can also find the error margin. That is the difference between, or the absolute between, my actual and my predicted. So 0. That's what I have. There's no value here because of the what's the name of this thing? Question mark. Okay. Now in a case where this is given, let's say there's 200, the actual thing, and this is 300 as the actual thing, this is 400 as the actual thing. Don't worry about the model output here, because these are just not to scale. I have my error margin. I can use this model to predict the next year. So if I want the fake price, I come to here and I just drag or double click. If I drag, it should give me the 5th year price. If I want the 8th year and I drag this, it means it's going to use T equal to 8. So let's check this out. So my T25 is this one. My U27 cell is it has highlighted is the U here. S37 is the 8. And so this is how you can use this simple model to find the asset price at any given time T, and you can find the error margin. This is one application of differential equations in our field. There are other applications, but since this is what we did in the lecture hall, we'll stick to this. So this brings me to the end of my video. I hope it has been helpful. Let me take you back to the rate of change. I had some comment as to the typing of the equations. Someone says that's too much to type. So just as I did with the differential equation, you can easily copy and then paste them. So this one here I can delete, copy this total cost, paste it here, but you don't need to evaluate it as a numeric. So I bring the equal to, wherever I see X, I know it's going to take this value. So X is going to take this cell. So 8 times the next cell becomes a 1. I don't know why it's not working. So equal to, let me paste this. So copy, paste, the cell of A100 plus 30. Let's see. Oh, I didn't bring the equal sign. It's not evaluating. Wow. Anyway, so you can try it out. It should work just as I did here, copy and paste and doing the editing. Alright, so I just stop here. All the best.